Okay, everyone should have page 1 of the worksheet using trig identities. We are going to look at the examples at the bottom. Make sure you write everything in your notes because they will be counted as a grade on Thursday when I get back from Houston. Okay, so the first thing that you did today, you should have made flashcards. Again, these are going to count for a grade, and you have to memorize this information. These are the 11 critical identities that we're going to have to know because we're going to use those to get our answers. Okay, so work on memorizing these every night. Practice with your flashcards. So let's look at example 1 at the bottom. And they've given us the sine of theta is 5/13. We are in quadrant 2. Okay, and they've asked us to find cosine and tangent for the same angle. Okay, so we are not going to use our x, y, and r formulas. We are going to use the identities. So it says to use the first Pythagorean identity to solve for cosine. The first Pythagorean identity is sine squared plus cosine squared equals 1. And the reason we're going to use that is because that's the only equation that has sine and cosine in it at the same time. Okay, so sine of x, or sine of theta, I'm going to replace this theta with an x because they mean the same thing, is 5/13. So in this first spot, I'm going to put 5/13 squared. This is just like Pythagorean theorem. I don't know what the cosine is, so I'm going to leave that as cosine squared of x, and then equals 1. So we're going to solve for cosine of x. So the first thing we need to do is square the 5/13. So 5 times 5 is 25. 13 times 13 is 169. Okay, now just like you would on Pythagorean theorem, we need to subtract the 25/169 from 1. And to subtract fractions, we're going to need a common denominator. Okay, so we're going to end up with cosine squared of x equals some number. Okay, and to get our common denominator, it's going to be 169. So the 1 I'm going to change to 169/169. And then 169 minus 25 should be 144/169. The denominator does not change when you subtract fractions. Okay, now we're not quite finished because the cosine squared equals 144/169, but we just want cosine. So we're going to square root both sides. The square root of cosine squared is cosine. And this time we've got to decide if it should be positive or negative. So if I'm in quadrant 2, that's where this part comes in. If I'm in quadrant 2, should the cosine be positive or negative? And it should be a negative because cosine's only positive in 1 and 4. The square root of 144/69 is 12/13. So the answer for cosine would be negative 12/13. Okay, so for part B, it says there are 2 answers to this equation. Explain how you knew to use the negative solution, and it has to do with the quadrants. We're in quadrant 2, and we are looking at cosine. So cosine is negative in quadrant 2. Okay, now the last part to this question is to find the tangent. So we need to look at an identity, and we want to find something that uses sine or cosine to find tangent. So let's look at the identities we've been given. Okay, so for tangent, it's only written in 3 places. So right here it says tangent equals 1/cotangent. I don't know what the cotangent is, so I'm not going to use that identity. Okay, I also have this identity and a Pythagorean. But again, I can't use the Pythagorean because it uses secant, and I don't know what the secant is. I do know what the sine and the cosine are, though. So let's use the quotient identity to solve for tangent. Okay, so the quotient identity is tangent of x or theta, whichever way you want to write it, equals the sine divided by the cosine. So let's substitute our values for sine and cosine. The sine was 5 over 13 divided by the cosine we just found was negative 12 over 13. Now remember, when you're dividing fractions, the first one stays the same, but you have to flip the second fraction. So that would make it negative 13 over 12. You can put the negative top or bottom, it doesn't matter. Okay, and when we do this, I can cancel the 13s because I've got one on the top and one on the bottom. So I'm going to end up with a negative 5 over 12 for tangent. Okay, let's look at one more example, and then you are going to do some practice. Okay. So the question says, Q is a rotation angle that terminates in quadrant 1, and tangent is equal to 3. We want to find the secant and the cosine. And it doesn't matter what order you find them in. On your homework, you're actually going to find everything that's missing. So you would also have to find sine and cotangent and cosecant. Okay, but on this one, they're just asking us for these two values. And since we're in quadrant 1, that means that all are positive. So we don't have to worry about positive and negative signs. Okay, so if you will look at your identities again. Okay, and if we've got the tangent and we're trying to find secant, tangent and secant are only related with this Pythagorean identity. Okay, so what we're going to have to do is use 1 plus tangent squared equals secant squared. Okay, so let's substitute for tangent. So our value for tangent was 3, and we need to square that, equals secant squared. 3 squared is 9, so we've got 1 plus 9 equals secant squared. Add those together, and we've got 10 equals secant squared. Okay, so we need to find the square root again, because I don't want secant squared, I just want secant. Okay. And when we square root this time, remember we said all the values were positive because we are in quadrant 1. So secant x is positive square root of 10. That's one of your answers. Okay. Now for cosine, if you look at your identity list, we know that cosine is equal to the reciprocal of the secant. Okay. So we could put in our value for secant, which was square root of 10, and 1 over square root of 10. You could rationalize that. For now, I'm not worried about the rationalizing, so here is your answer. 1 over square root of 10 is the cosine. Basically, if it's a reciprocal identity, you are just flipping it upside down. Okay, now you need to practice this on the homework, but again, be sure to read the instructions because you're not just finding two values, you're finding all the trig functions that are not given to you. And show all work.